Okay, and so today we're going to look at spotting the pattern again, and this time it's to help us to find the general term in a linear sequence. Okay, so how do we come up with a rule for any sequence? First of all as well, so that would be a rule like this one here, 2n plus 10, 2n plus 2. So some rule that will work for the whole sequence. The other thing, the reason it's called a linear sequence is because if I were to draw it, it would form a line, shape of a line. Okay? Okay, and so just before we begin with an example, we're just going to have a quick look here. So it says a linear pattern or a sequence. For it to be a linear pattern, basically the change each time has to be constant, because otherwise we wouldn't get a straight line. So in order to have a linear sequence, the change must be constant. Okay, so the change in a linear sequence is constant. It doesn't change. Okay, here, and we call that change the difference, we call it the common difference. But always, if we have a linear sequence, one, it will form a straight line, and two, in order for that to happen, the change between each term has to be constant. Our rule then, so the general term of a sequence, that says basically it's the formula that can be used to find any value that we want, the value of any term in the sequence. Okay, so we're going to do a little example here now, and it says find the general term of the following sequence and hence find the 50th term. So always when we're trying to find the general sequence, the general term of a sequence, we begin by drawing a table. So step one is to draw a table. And so we begin and we will draw our table. So here I've begun to draw my table. So now I'm going to write down term number 1, 2, 3, 4. And then from the example that we've been given, the sequence begins 2, 7, 12, and 17. So the first thing that I want to see is, well, what is the change between each term, and is the change constant? Because if it's not a constant, we don't have a linear sequence. So to go from 2 to 7, well, I know I'm adding on 5. Here to go from 7 to 12, also I'm adding on 5. And to go from 12 to 17, I'm adding on 5. So the first thing I know here is, I can notice my change is constant. So as I've noted here, my change is constant because it's going up by 5 each time. Now, so the next question that I ask myself, and this is really, really important, I ask myself, what else or what also goes up in 5s? And so I remember from my maths in primary school that the 5 times tables go up in 5s. Okay, so, and we're looking for a general term. So we want something that we can put an n into. So if I want to put an n into it, I could call that 5n. So from that, I'm going to see, can that give me a general formula? Okay. Okay, so now that I've established that 5n from my 5 times tables, because that also goes up in 5s, which is our common difference, our constant change. Now that I've established that that might be a rule, I need to test it out because it's going to need some adjusting to fit this formula. So here, so the first thing that we might say then is, for our general rule, that Tn is equal to 5n. Okay, so now I want to test that out. Test it out. So I might say T1 equals 5 times 1, which is 5. But if I go back now and I look here, I see that I don't have 5 on my table, I have 2. So I know, how do I get from 5 to 2? Well, I would have to take away 3. 5 minus 3 would give me 2. So now I can adjust my formula, my general rule, to say 5n minus 3. And this will be my general rule. But again, I'm going to check it out, test it out to see does it work. So very quickly I'll test it out and I'll say I might try this time any of the ones from the table. So this time I'm just going to try T3. So here I'm going to say, well, that equals to 5. Now, instead of n, I'm going to use my 3, which I've replaced beside the t. And here then, from my formula, I have minus 3. And I can see, well, 5 by 3 gives me 15. 15 take away 3, well, that equals 12. And if I go back up to here and have a look, well, the third term is equal to 12. So I know that this formula and this here, so this formula is correct. So we've been asked in the question to find the 50th term. Okay, so here very simply then, in order to do that, I'm going to just write part 2 here. So I'm asked T50 equals question mark. So what will I do? Again, I'll just write T50 equals, and I have my 5 here, and instead of n, I'm going to write down 50, and I have my minus 3 from the formula. And so I know, well, 5 by 50 is 250, take away 3, well, that equals to 247. Just a recap there on how do we find the general term. Well, the first step we do, we draw a table. Then number 2, we calculate the common difference. Now, that common difference must be constant in order for it to be a linear sequence. Okay? If it's not constant, we don't have a linear sequence. And then number 3, I ask myself, well, what else goes up in that amount? And so generally I will say that's my common difference, my d, multiplied by, I put it beside an n for any number. And then number 4, I adjust that formula or that rule so that it works with my sequence. And that's it. Very simple there. And then again I test it out just to make sure that I'm correct. Okay, so have a look at one of the questions and off we go.